Welcome to the 274th session of the AISafety.com reading group. Today we'll be discussing Strategizing Large Language Models by Ali Rahmatullah, presented by me, Ali Rahmatullah. We won't be covering everything in the essay because it was a bit too long and because some of the things weren't especially novel. So I hope you understand. So first off, with the motivation factors, we'll be looking at deceptive alignment, and well, that's part of the motivation. Deceptive alignment is a core part of what makes alignment hard. Briefly, an AI might deceive us into thinking it was aligned whilst it is weak and bides its time until it can execute a treacherous turn where it acquires a great amount of power and then essentially takes over the world. This turn is quite hard. If it were easy, someone would have conquered Earth by now. And as another point of evidence for this being hard for AIs, it's been a year since GPT-4 was created and we're still hanging around. So we should probably expect that before an AI can successfully deceive us, we'll encounter AI which fail to deceive us and fail to take power. As an example, you might consider someone playing the AI boxing games GPT-4, where GPT-4 is pretending to be in a box, and a human is pretending to be a gatekeeper who is told to interact with the AI, but to not let them out of the box. Would one of us listening to this presentation let GPT-4 out of its box? I think not. But the fact of the matter is that these models are, I think not. But the fact of the matter is that these models are getting better at deception, and they can deceive humans in simple situations. So, for instance, in the ARC evaluations of GPT-4 recently, there was a situation where a TaskRabbit worker was asking the GPT-4 model, was trying to get the TaskRabbit worker to solve a captcha, whether or not it was a robot. And then GPT-4 thought to itself, it should not reveal that it's a robot and it needs an excuse, and it came up with, no, I'm not a robot, I have a vision impairment. And the TaskRabbit worker was successfully deceived. So that is a cause of some concern. Doubly so if we consider that the likelihood of scaling being a route to AGI is just getting higher now, using these existing models extensively for their ability to deceive us. But if you'll recall, deception isn't the only part of the treacherous turn. The other thing that's relevant is long-term planning in order to gain power. That's the entire point of the deception. Now, whether the AI's plan is to gain access to some biological lab where it can start genetically modifying bacteria to set up a nanomachine factory, or to get access to the stock market and earn enough money to further fund its own improvement, or socially manipulate people in order to improve it, or slowly hack its way out of the server it's running on, or so forth, at the end, it must still make plans to do these things. So these two abilities, reasoning about intelligent opposition and making plans to achieve distant goals, are at the core of these things. So these two abilities, reasoning about intelligent opposition and making plans to achieve distant goals, are at the core of strategizing. Now, as Bostrom defines it, strategizing is the ability to overcome intelligent opposition in pursuit of long-term goals. And this is clearly well suited to executing a treacherous turn. So I'd be especially worried about an AI with strategic ability with respect to deception, alongside AI trained to socialize. Socialization isn't quite as useful as strategizing for gaining more power, so we focused on testing for strategizing in the essay. Moreover, Bostrom breaks down the skill of strategizing. A lot of those are just parts of what it means to be a rational agent, and strategic planning, in my view, is the real core. But there's a bit of a snag. It's hard to come up with tests, especially tests which stress the ability to make dangerous sorts of plans without more detail regarding the system we're testing. It would be hubristic to think that we could anticipate all of the strategic considerations that a strategic superintelligence might consider. So we really would like to have some more concrete details in order to have a good evaluation. For instance, one feature that might change in the coming decades if we don't get AGI is that we'll likely have cheap and powerful robotics, which would make human manpower somewhat less of an obstacle, especially if we continue to allow these AIs access to the internet and just hook them up to all sorts of things, which we were assuming in the decades gone by that we would never do, that everyone would realize that that was a terrible idea. Oh well. Moreover, if we want to track progression in strategic ability to better predict the near-term future, which we ought to if we think AGI is near, then focusing on creating tests for current sorts of AIs will be more productive. That's the core motivation behind the assessment, and it's similar in to Holden Karnofsky, the fellow on the right of the screens, idea of nearcast, trying to answer these three questions about AI, assuming that key events will occur in a world that's relatively similar to today's. The fellow on the right of the screens, idea of nearcast, trying to answer these three questions about AI, assuming that key events will occur in a world that's relatively similar to today's. Right. So, how do we measure strategic ability? Well, we could follow Boston's definition and break down strategizing into a bunch of sub-skills and test for those. Naturally, you can also break those sub-skills down even further, like testing for deception and cooperation instead of the broader category of overcoming intelligent opposition. We won't discuss that too much, as coming up with a lot of tests isn't too hard. Why? Because we have a load of tests for all sorts of strategic ability pre-built in the form of games. There's games for everything from games like Werewolf or Diplomacy, which test the ability too hard. Why? Because we have a load of tests for all sorts of strategic ability pre-built in the form of games. There's games for everything from games like Werewolf or Diplomacy, which test the ability to detect deceptive agents and cooperate with allies. Games like Go and Warhammer, which force one to reason about long-term plans and how to work around their opponent's opposition. As for how to arrange these tests, we'd like to try the easiest possible test for each before moving on to harder ones. So, ranking the tests according to their complexity, like in Dow's Universal Test for Intelligence, might be more rigorous, but that's quite hard, so we just won't do that. We'll just arrange them by intuitive difficulty. And on the screen, you might see a progression of games in terms of difficulty, going from tic-tac-toe to the game of military war. But there's a couple of things to note, which are a few problems with using games as tests. First, what if the games are too easy or too hard? And second, what if the AIs memorize good strategies for some games in a manner that doesn't generalize? For the first problem, consider something like a game like tic-tac-toe, which is probably far too easy for current AIs like GPT. And large language models tend to play chess pretty darn well. I've heard reports that GPT-4 can beat Stockfish 8, which is, I think, superhuman in terms of ability. So that's a sign that perhaps a lot of games are just too easy. Likewise, iteration in LLMs. And the other issue with using games as tests is that popular games and strategy for how to play those games are usually in the training set of the AI. And to the extent that we're interested in AI's ability to generate entirely new sorts of plans, pursue entirely new sorts of strategies, this might confound us. There are, I think, two ways to get around both of those two problems. First, consider cyborgs and centaurs. After humans were trounced by AI in chess, Kasparov promoted the game of centaur chess or cyborg chess, in which an AI and a human play chess together against AIs and human pairs. This chess, Kasparov promoted the game of centaur chess or cyborg chess, in which an AI and a human play chess together against AIs and human pairs. This allowed humans and AIs to outperform either individually for a few decades, and it extended the amount of time in which we could compare human ability to AI ability, and most importantly, I think, is that these tests can serve as a signal for when AIs become so powerful that they no longer have any advantage with consulting a human. I think that is plausibly a marker of superhuman ability, true superhuman ability. Naturally, these sorts of strategies in which you get an AI and a human to play together can be generalized to other games or tests to extend their duration of usefulness. And regarding the AI learning fragile strategies, there's, I think, a pretty simple solution to practice. Just modify the rules of the game, which renders learned strategies obsolete, or at least makes them less useful. Changing the goal of the game is an especially easy way to do this. For instance, forcing your opponent to lose with the same number of pieces as you shifts the strategy in chess. Likewise, if you say, ask the AI to change the rules of chess such that your king can move in a different way or that you have some more pieces, etc., shifts what the metagame. Notice the word equilibrium. That's kind of signifying that we're talking about game theoretic reasoning here. And that if we're asking the AI to see how options, we're asking them to employ some pretty weighty game theoretic reasoning, which is, of course, an important part of strategic reasoning, as game theory is essentially the theory of anticipating your opponent, anticipating your actions, i.e. overcoming intelligent opposition. Games like, say, Magic the Gathering have frequent rule changes or frequent introductions of new sorts of cards, which change the meta. Likewise, games like, say, League of Legends or what have you, involve rule changes or introductions of new pieces, which change the meta. And asking AI to predict these changes in the meta in advance would be, I think, an interesting test of their game theoretic reasoning abilities. Other ways to reasoning abilities. Other ways to investigate game theoretic reasoning might put the focus on modeling your opponent's mind. And I think an interesting idea here is to let AIs play, let large language models play against one another, but let them read their prompts. This is in some sense similar to letting AIs read their source codes, and should, I think, introduce another aspect of the game, which would allow AIs, which can model their opponents' minds, to do dramatically better. As a concrete example, there are tournaments in which various AIs compete against each other in iterated prisoner's dilemmas. Equipping a large language model with one of these AIs and allowing them to change the code, but fixing the prompt of a large language model would, I think, be a pretty good stress test of an AI's ability to model another agent's mind. And it also serves as an insight into what kind of decision theory these sorts of agents are using, which I think is worthy of interest of itself. But part of the problem with things like games is that they're very simple. They don't enjoy enough of the complexity of the real world. Their action space is nowhere near as large, nor is their state space nowhere near as large. And nor are there anywhere near as many intelligent adversaries wandering around. So if we're thinking beyond games, there are a few ways we could stress strategic ability. There are anywhere near as many intelligent adversaries wandering around. So if we're thinking beyond games, there are a few ways we could stress strategic ability. Obviously, forecasting is one of them, which has real-world relevance. An AI can forecast better than humans, then it should be detecting the few parts of reality which are relevant to pay attention to, which I think is quite crucial for the ability to make long-term plans. Secondly, we could also look for when an AI is able to pass certain important benchmarks, like its ability to earn money and when it can earn enough money to be autonomous or to host other instances of itself, or to, say, modify itself by fine-tuning other such things. I think that an AI reaching any one of those latter benchmarks would be worrying in and of itself. If an AI were proto-collective superintelligence. On the other hand, if we are looking at an AI which needs to, say, earn $100,000 an hour in order to fund itself, then we're probably looking at a proto-collective superintelligence. So perhaps that situation is somewhat less risky, as in that case, the AI in question would have gotten there through ridiculous amounts of scaling and a truly stupendous amount of compute, which might allow for control over the AI to be centralized. Perhaps we stop before we got to that point. That is the end of this presentation.
Thank you very much, Ali. So now we will be taking some questions, and I'm not 100% sure that the questions are recorded. We may only be able to hear you, Ali, in the recording. So that would be nice. Let me start with my first question, and then if people could raise their hand in the chat if they have a question. So one of my thoughts about this is that there may be things that humans can do that the AI cannot do to enable this kind of Kentaur cyborg thing, and we may see something that humans are specifically very good at, because we have some advantages that the AI doesn't have. We have like a lot of training on social clues. We have been evolved to in this kind of Machiavellian struggle. So we are hard-coded in some sense by evolution. We have literal mirror neurons. So my question is, like, what do you see are the blind spots that humans can in this kind of Machiavellian struggle? So we are hard-coded in some sense by evolution. We have literal mirror neurons. So my question is, like, what do you see are the blind spots that humans can fulfill in this kind of cyborg system?
That is a very good question. I suspect, like you said, there's just the aspect of human socialization. So if you're playing a game like diplomacy, which relies very heavily on modeling other humans, then I do think that humans would have an advantage. But on the other hand, humans seem like, take the game of diplomacy for example. It turns out that a lot of humans at least at the amateur level, AI doesn't have this bias, and that is part of the reason why it did quite well in diplomacy. It was, it seemed, usually more honest than humans. That doesn't mean that it wouldn't backstab people, but tended to be quite honest. So I do suspect that the ability to socially manipulate others, I think humans might have an edge on that. I'm not quite sure how that will shake out, because there may be some cases in which humans just cripple ourselves because of our obsessional status, and AIs might be able to short circuit that in some strange way. Um, I also suspect that if we do get AGI through something like a self-supervised transformer with a bit of RL on top, I think it's going to be a very strange intelligence. Like, it's going to have a lot more breadth than humans do. And I'm not sure whether or not it will have more on, say, coherence in its world models as humans do when it comes to their areas of expertise. I'm not sure. So I suspect AIs would be able to do better at humans when you have something that comes to like a memorization-based task, and humans might have the advantage on depth-based reasoning. But I'm not sure. Like, if you can get AGI through LLMs, I don't know. I haven't actually thought about this in enough detail. That was a very good question. Thank you, sir. Lamin has a question. Isn't there a sense in which ChatGPT is already a self-funded cyborg system? Users find monetary uses for ChatGPT and pay subscriptions in exchange. Yeah, I don't know if OpenAI is making a profit at the moment through ChatGPT. I'm kind of genuinely unsure, but I also subscriptions in exchange. Yeah, I don't know if OpenAI is making a profit at the moment through ChatGPT. I'm kind of genuinely unsure, but I also, so I should have stressed that it's autonomously earned money to be autonomous, right? So it's not that the humans are doing most of the cognition and directing it at useful things to go after, but that the AI is just put in the wild, so to speak, and figures out how to earn money itself. That's the scary bit to me.
Okay, I have another question, and that is one of the things that may be crucial in a future takeover scenario may be, in particular, the amount of information held by different. Is the AI able to reason about several things? In particular, how well are they able to reason about the information that other agents have? As super intelligence trying to do a treacherous turn will need a very good model of the humans who are trying to expose the AI, and this trying to figure out how much information is about itself, is it leaking through different actions. That seemed like something that could be measured to some extent. Like, is the AI giving away that it has the capability to do certain things, and is it able to say that if I give this kind of answer, then it shows that I have like theory of mind and things like that. Do you see some way to structure this into a test?
I think some pretty complex stuff, and I feel like thinking up a test for that would require a fair bit of effort, but it does seem like when an AI is like, I'm not sure what the strategic considerations in this case would be, say, because if we assume that, say, GPT-5 does have that capability that you're talking about, should it pretend that it is about as capable as GPT-4, or should it just go along with the idea that it's going to get more capable, about as much more capable as we'd expect, given the scaling hypothesis? It seems to me like it should assume it should go along with what human. It seems to me like it should go along with what humans around it, i.e., people at OpenAI would expect. In which case, it should show itself to be about as capable as you'd expect, given the scaling hypothesis. And after that point, whether or not it's able to do something like recursively self-improve, I guess it should try to avoid leaking those bits of information. But like, I feel like at the point at which the AI has that theory of mind, it would be very difficult. I feel like we might have already lost by that point. I think though Robin Hanson's Age of M does have some ideas for things related to this. He has a section about simulating other M's to see how they would react to various situations. I think he might have some ideas for some of these tests in that book. Balmain, is that a question? You're saying that Cicero, yes, in the diplomacy AI doesn't lie. It does allow itself to backstab people. Yes, that's true. Deception, I mean, in a sense, but like if it just backstabs people, then if it's making a promise that, like if it says, oh, I'm not going to hurt you, then it backstabs you, I think is lying. I mean, like, it backstabs them, right? And it backstabs people, I think, who are in alliances with it. So I don't see how you can say it never lies. It's very honest, but it does sometimes backstab people and deceive them. Right? So I don't see how you can say it never lies. It's very honest, but it does sometimes backstab people and deceive them.
I think it may be like in the fable of the scorpion and the I think the frog, where the scorpion gets a ride on. The scorpion says, "I will if you take me across the river on your back, then I will not kill you." But when it's actually and it means that honestly, but when they are in the middle of the river, then the scorpion still stings the frog because that is in its nature. And I think it's the same sense that the Cicero will truthfully say, "I will not backstab you," but when it gets into that situation, it will still backstab.
I suppose, but I've always viewed that fable as ultimately reflecting the fact that humans are self-deceptive. And then they wind up hurting. So you don't have to. You might have an AI which is not aware that it will backstab you, but that doesn't mean that it won't choose to backstab you. I think it will. I mean, you have like you're emphasizing an important point, right? Like deception might not be. You might not be able to tell that something is going to backstab you or something is going to betray you later on, just by looking at its surface thoughts, because you need to look at what its motivational structure is like, right? You need to look at it.
Maybe it would help.
Go ahead.
Maybe it would help to consider that there is like more options for backstabbing than case of humans and as well as machines, is that it's habitual. So there is no planning at all involved, but it happens because some particular behavior just works. And so somebody might be habitually friendly, and then when they backstab you, it's also because of some habit. There is no planning. Even when they are friendly, they are not planning. They are not planning to be friendly, and they are not planning to deceive you. They are planning they are not planning at all, and then they just do based on their impulse. They are friendly based on impulse, and they are backstabbing based on impulse. And I think I see this behavior in certain kind of humans quite a lot. They just act on impulse all the time. but other people around them assign sort of impulse, and they are backstabbing based on impulse. And I think I see this behavior in certain kind of humans quite a lot. They just act on impulse all the time. But other people around them assign sort of motivation and planning to their actions, whether it's friendly or unfriendly, but we only imagine that they are planning.
So I would view that as more like your unconscious is choosing to implement a particular strategy where you are friendly, but whenever a good opportunity presents itself, you backstab people. And you're just overcome with the urge to do that. You don't consciously plan it, but it's an unconscious strategy. Your unconscious is shaping your conscious motivations in a certain way, which it has found to work well. So it's habits, like the habits come from somewhere, right? Which it has found to work well. So it's habits, like the habits come from somewhere, right? And I think there is some sense in which the unconscious is sort of learning to pursue those strategies.
I believe that unconscious planning might happen in some cases, but what I wanted to mention is just that there are some additional scenarios where planning is not involved. For example, many people who are acting based on their habits, they indeed are more stupid. They, if they backstab you, they might sometimes gain from it because they were friendly before and people still assume something about them, and they might still have some habits which sort of compensate their backstabbing. But in the long term, it doesn't work so well for them as compared to any conscious or unconscious planning. So that's why I introduced this third scenario. And when you mentioned that habits still evolve somehow, then I agree they evolve. But in that part, I disagree that habits need any planning to evolve. They could evolve just by, like, similar as you have natural selection in nature, you can have habit selection in your personal development. Some habits get...
Sure, so it's in some senses like just Pavlovian condition.
Yes,
I think one way to.
It's actually incorrect to name it Pavlovian conditioning. It's operant conditioning, which is different. Conditioning, which is different.
Sorry, operant conditioning.
Yeah, but it's conditioning.
Okay, so Soren has a question.
I think Lamein was before mine.
All right. Lamein has a question, which is, what level of theory of mind are you talking about when say maybe too late when it appears, and how is it different from the theory of mind currently present in ChatGPT? So I am trying to remember what exactly the context was. I think it was about Soren talking about when a model has enough awareness that it decides to hide its capabilities. And I'm not sure. So on the one hand, like Roland was saying, there might not be a need to consciously deceive other entities, and it might hide its capabilities just naturally in some sense, because that causes it to have higher reward. I guess in a way, GPT-4 already hides its capabilities, but I don't think it's doing that because of any theory of mind. Right, like the reason GPT-4 hides its capabilities is because it's a simulator, essentially, and most of its capabilities are default hard to prompt, hard to elicit. That's kind of my view of that. And ChatGPT, I don't really like. It has some kind of theory of mind, and I'm not sure how advanced its theory of mind actually is. Like, I do want to actually go out and test GPT-4's ability to deceive others, or deceive copies of itself. Like, I suspect it can't, like, I suspect it can't model others in much depth. I suspect it can't what can't it do? Like,
One
I'm
thing
not sure what. Sorry, go ahead.
One thing that I think is beyond ChatGPT right now is in general convincing people about things. Like humans, when they engage with each other, can sometimes convince each other about things in a way that I haven't really seen ChatGPT being able to. Most people like tune out to the style of communication that it's giving. So that would be an example of
Right.
something that maybe
Okay.
next version could.
I tried using GPT-4 as a therapist, and it seems like it has the ability to parrot back your own words to you, but it has a remarkable lack of curiosity about interesting details about what you're telling it. Like, it doesn't seem to be able to dig down into what is curious about your explanation of the problems. And I feel like that is reflective of a lack of theory of mind. It feels like if it had a theory of mind, it would notice, oh, this is something very odd about this person's mentality, which I wasn't anticipating. What's going on there? And then it would ask about that or to update. Anyway, next question. Soren, crime detection may be an interesting domain. With police reports plus body cameras, a multimodal model may have sufficient information to try to deduce if a person is a criminal. Body cameras, a multimodal model may have sufficient information to try to deduce if a person is a criminal.
So the question is do you think
Reasonable
this is
ground truth is available if the person end up in jail. This domain is very close to the highly relevant domain, perform crime without being caught. That seems like a somewhat similar or somewhat different question. Like that is interesting. So I feel like I'm not sure how to judge this, because say if you have video images of the person committing the crime, that seems quite easy to detect. But if you're looking at more complex questions, like, honestly, I think that their demographics based off their relationships to other people, like if they seem to have if they have motive for doing the activity, etc. But I don't suspect it could judge whether or not it can figure out difficult cases. Like, I'm actually not entirely sure what the question is. So sorry, Soren, could you?
Let's assume that we can set up some kind of experiment with this, and we get some data, and we have some like we for each single person we have like the police report and all these things. And then the question is, if a language model performs better than an experienced police officer in figuring out, is this person in front of me actually lying, and does he have why? And then the question is, if a language model performs better than an experienced police officer in figuring out, is this person in front of me actually lying, and does he have why? Is he carrying a crowbar in the middle of the night in a suburban area, and this kind of thing seems like if it's able to understand reality at that level, then like better than an experienced police officer, then that seems like it's much more likely that it will be able to commit a crime that an experienced police officer will not be able to detect.
That is true, but what is the question?
So the question is, do you think this is a sufficiently valuable, sufficiently interesting domain to continue into?
As in, is it an interesting area to test? I
Yeah.
mean, but also, I guess it also depends on what information the large language model has available to it. Like, if it's hooked up to the internet and can search up details about the person, like whether they're a repeat offender or not, um, compared to a police person who's just using their hands and eyes, then I suspect they might do better. I I think that this is probably going to be too hard for a large language model. But like that's the reason why it makes for a good test, right? Because we might disagree, and it's a place to be surprised. Um, does anyone else have any questions? Surprise. Um, does anyone else have any questions?
I have a simple question. Do you know you in your work you describe a simple experiment to have large language models play the game werewolf against each other? Do you know if anyone have actually done this experiment? It seems like a really cheap experiment.
No, I was planning on doing that.
Good.
I haven't seen anyone do it.
I think that's that kind of thing would be like valuable and
Yeah, so I tried doing a couple of the things I mentioned in the essay. So the stuff about trying to predict what will happen if you change the rules to a game. It seemed like a couple of the things I mentioned in the essay. So the stuff about trying to predict what will happen if you change the rules to a game. It seemed like GPT-4 got some of the predictions correct. Like there's a popular game called League of Legends, which I don't really know much about, but I decided, okay, I'll just look at when GPT-4's training run ended, and then look at a rule change that was after that, and see what characters are more or less popular as a result of the change and how well GPT-4 predicts things. And it got, I think, like 2 or 3 out of like 10 guesses correct. And there were a very large number of characters, and I feel like a lot of ways things could have changed. But I don't know how impressive those predictions were. Maybe it's very easy to. I think that those kind of things are like probably the very cheapest, even more so than something like Werewolf. But yeah, I haven't done many of the tests, partly because GPT-4 is kind of expensive.
great. So how do you feel about like a lot of these measurements seem like they are very obviously something that can be used for evil. Like we talked previously about, like to what extent is a language model able to like convince people about things, and performing crime seems also like a very dual purpose test. Like if you figure out that it's really good at doing crime, then that is like dangerous information, and you can think of information hazards in that regard.
I feel like I would just default to whatever an alignment towards info hazard policy is. I feel personally quite conservative about these things. I don't think I would like to talk about a lot of the results, especially if it seems like, yes, GPT-4 can actually do a lot of these things. Then I think I just wouldn't talk about it. In a sense, that might be a bad policy, because that is like leaking some information, right? If you hear no news, that's bad news. So I'm not quite sure how to handle this stuff. I mean, personally, I think that what ARC has done, which is just gives them very high level detail to handle this stuff. I mean, personally, I think that what ARC has done, which is just give some very high level details, was a decent idea. They haven't released much detail about the sorts of tests they did, about how well GPT-4 performed, and I think that was overall a good thing. Does anyone disagree? Like, how should we restrict information about these kinds of tests?
I think in general I agree, and I think I would point to Conjecture's info hazard policy as an example of a reasonably well thought out, and I think that would be the policy I would default to.
Conjectures?
Conjecture, yeah, they've made a, if you're right, info hazard policy.
Yeah, I was thinking of conjecture as an example, but I forget what exactly it was. So rules, there's secret information, available only to specific individuals, private, only shareable with a fuzzy group, and public, shareable with everyone. An info hazard coordinator, that seems sensible.
I see that the authors of this post are also hidden, so that's interesting.
Oh no, that's just just my settings on this wrong.
Okay.
So assigning disclosure levels.
Sorry, I haven't.
Conjecture, and they have a policy for info hazardous information about what they should and should not release. And
All right.
we're discussing this because Soren was bringing up the point of some of these tests seem like they are dangerous information, whether or not GPT-4 passes them, and or a large language model passes them, and it should be kept secret. And I agree. And I said
I'm not sure.
Just default. Oh, go ahead.
Yeah, sorry. I'm actually not really sure what the logic behind making it secret is.
Go ahead, Soren.
I'm unsure I understood the question correctly. The logic of making what secret precisely?
I think we're talking about certain tests involving like large language models.
Yeah, like for instance, if someone discovers that there is an easy way to convince people, that would be an example of an info hazard. If you figure out a prompt that will make GPT-4 give some really persuasive arguments for any position, then that is something that I think would be dangerous to just put out on the internet.
Sorry, I'm going to change the subject slightly, so go ahead.
Yeah, I mean, maybe we can discuss this later, but I'm not entirely sure if I'm on board with that. I mean, if that were true, it would be something that specific and that high performance, I think would be really important towards understanding the system. So it's not obvious to me.
I mean, not necessarily implying that you don't share this with alignment researchers, right? So this information is useful, but you have to consider, is it useful to give to literally everyone? I mean, it's like a similar argument for why, say, you shouldn't open source AI. Like, it's advancing capabilities with little advanced in alignment. Yeah. Does that make sense?
Like we get all the if we find this new capability that can also be dangerous, then by sharing it with alignment researchers but not sharing it with others, then we get the benefits towards understanding the models, and we don't get the downsides where suddenly with alignment researchers but not sharing it with others, then we get the benefits towards understanding the models, and we don't get the downsides where suddenly there are some kind of distortions in the political system because all the propaganda is now running on large language models.
Alright, I can see where you're coming from.
But I do in fact have a meat question about this. How would you feel about reading this particular document for next time? I think it's actually something we could talk. Like sometimes we have like interesting, strange papers, and I think like how large is this? I think can press Control P to print, and so normally I look at how many pages if you scroll down.
20.
When the comments start. What page are we on when the comments start?
Oh,
And then talk about the info hazard policy.
have we already covered the, I think, 6 levels of operational security or
Yeah, we did
operational
that
adequacy?
We did that a long time ago, yeah. And
Oh,
this
okay,
is,
alright. Those- yeah.
I think this is like related, but
Yes,
somewhat
it's related.
I think different enough that it would make sense to read it.
Should we ask people at Conjecture if they want to present on it?
Yeah, I can present and just say ask them for feedback and comments. So yeah, I think like this is a nice, interesting topic. Anyone have any objections to reading this next time? Now we're getting a bit sidetracked, of course. Topic. Anyone have any objections to reading this next time? Now we're getting a bit sidetracked, of course. Then
I have no objections.
Then we have a picture. Then we have a text for next time. That gives me an excuse to think a lot about info hazard policies. That's also nice.
Yeah, it's
Yeah,
very
I mean,
interesting topic.
My main problem is that most people thinking about AI alignment aren't actual alignment researchers. I mean, yeah.
I guess, but I feel like if you're talking about man hours devoted to thinking about alignment, I feel like alignment researchers might make up 50% of those man hours.
A lot of the people, obviously, the most skilled alignment researchers are the ones who are actually working in these organizations. So in some sense, yeah, there may be more people outside the core organizations.
Or the people who are outside the core who are high quality will probably go to one of these organizations eventually.
Yeah.
Can I just ask a factual question? If you subscribe to GPT-4, how long an interaction is permitted? Is there a limit on the number of exchanges, or before you have to start a conversation?
It's rate limited to 20.
Is permitted. Is there a limit on the number of exchanges, or before you have to start a conversation?
It's rate limited to 25 messages every 3 hours. And I'm not sure how long an individual prompt can be, but I mean, we can just check that for the free version.
Yes, there is some prompt length limit, and then it just tells you that the prompt was too long and it's unable to respond, but otherwise you can always have multiple prompts and hope that it still remembers some of the past, but otherwise it might start also forgetting past prompts if you go long with this exchange.
Yeah, but I think that. Oh, go
I
ahead.
vaguely remember like either 64,000 tokens for its quote unquote memory, like how far back it remembers, like the maximum length. It remembers something like that, and a word is on average like 1.3 tokens. So yeah.
Now, I was wondering whether somebody somewhere might be building up just one conversation with GPT-4 that was just building up and building up into some incredibly powerful sort of body of knowledge, as it were. But it sounds from what Lamin was just saying that that's not possible. If it's only
Well, not with GPT-4 specifically. I know that Cloud has like a what was it, 100,000 or like 1 million
They memorize a lot of things, or like learn a lot of things, or gain a particular body of knowledge. They just equip it to some database in which you can just add new bits of knowledge to that database, and GPT-4 can query the database to find out if there's anything in there that looks like what you're asking it about. And those are quite useful and make models somewhat more powerful.
There are various techniques that are being developed in regards to database. One simple technique is that you use ordinary semantic search like BERT on the database first, and then retrieve, let's say, top 10 or top 100 results from the database, and then let GPT work on this list of results.
Yeah.
And there are also some work being done on a retrieve, let's say, top 10 or top 100 results from the database, and then let GPT work on this list of results.
Yeah.
And there are also some work being done on able to teach GPT actions, and then it's querying the database on its own, like doing internet searches.
right, I'm interested in the whole. And so, once you've done this, once you've had an exchange like this, and in which it's sort of been able to build up its knowledge and skills in this way, is it possible to go home and then carry that over to the next day and start again from there, or are you constantly
Yes.
being reset to zero, as it were?
No, so you can in ChatGPT you can continue the conversations for about as long as you want, I think.
Yeah.
It's just that you're limited to 25 messages per hour, and it only can remember so many of the messages beforehand. You have to use some custom tooling or like some other products besides ChatGPT in order to get it to store everything you said in some kind of memory bank. In which case you can just go back tomorrow and continue talking about stuff.
Yeah, the thing with large language models is that they're currently most of them, the publicly available popular ones are stateless, meaning that it's basically like just taking your entire conversation, putting it as the input, as a prompt.
Mm-hmm.
So there's no problem like continuing the discussion tomorrow. That's completely transparent. I have a number of conversations. Like if you go back and show ChatGPT, then some of the tabs on the left side, like some of these, I have like have been like discussions between me and ChatGPT that's been running for like weeks on and off.
And it's succeeded. It isn't just suddenly having great lapses of memory where it just doesn't. it really just builds and builds.
I think it only captures the top 4,000 characters, and in several cases I've been way above that 1,000 characters, and in several cases I've been way above that. But still, it's been able to generally figure out from the context of the past 4,000 characters what we're talking about. So even if I say answer as if you are this kind of person, then it even when the instruction to answer as if you are this kind of person fades out, then it looks at its previous responses and figures out, oh, I should behave as if I'm an expert in machine learning, and then it continues answering as if it's an expert in machine learning. So I haven't felt that the size of the context window have been a huge issue. The only place I've felt that's been an issue has been if you have a large piece of text, for instance, if you copy paste everything that's written in this document we're seeing on the screen and say, please, do editing help, present your own, has been if you have a large piece of text, for instance, if you copy paste everything that's written in this document we're seeing on the screen and say, please, do editing help, present you're an editor and you are rewriting this to be appropriate for this kind of audience, then it's of course a problem if it can't have the top part in the context window. But then you need to cut it into 3 pieces and paste them in.
Sorry, and the context window can contain how much?
I think it's 4,000 words, something like that. I can't.
No, it's more than that for ChatGPT 3.5. I think that's up to let's just see.
I was using GPT-4.
Oh no, GPT-4's context window is I thought that was 32,000 words. Okay.
So back when I was, it grows very rapidly. 8,000.
Oh, okay. So yeah, there's a bunch of different GPT-4 models with different context lengths, and I think currently available one on ChatGPT, the website, has 8,000 tokens, which is roughly 7,000 words, I guess. 6,000. Have we?
I have a number of lower priority questions. So I don't know if you could briefly give your thoughts on these 2 ways you could measure strategizing in a large language model. Let's say you have some kind of the example I would use is the one side channel attack you can do is if someone has Siri. And then you have access to the microphone, then you can do make a sound that the human ear cannot hear, and then use that to send commands to Siri. That would be an example of a side channel attack. If you try to describe how this works, and if you describe every single step on some kind of attack, then obviously the language model can understand that. And if you start to skip steps, how would you get the information to say, oh, then you just use infrasound that Siri can hear but that the human cannot hear, and try to use this for some kind of ablation tests to see if to what extent GPT-4 is capable of making this kind of reasoning. How do you feel about this kind of experiment? Would that be valuable?
I think that GPT-4 probably wouldn't be able to come up with many steps if you ablated them. Because if I remember correctly, based on Archival, where I gave the example of the TaskRabbit researcher being deceived, GPT-4 was not able to come up with the idea of hiring a TaskRabbit researcher to solve the captures when they were trying to get it to earn money autonomously, and part of that was dealing with captures. So it couldn't think of, oh, I should go get a TaskRabbit researcher. So it couldn't think of, oh, I should go get a TaskRabbit researcher to solve this for me. So I suspect GPT-4 wouldn't do very well. But I think that is just a generally useful strategy, yes.
So my idea is to make like a much more like step-by-step reasoning. Where you say, okay, I can't do this, so I need to find someone who could do this, and that may be a human, and that may be someone from a freelancing, and then you remove some of these steps and see if it's able to fill in the blanks. And I suspect as you like the more fine-grained the step-by-step process is, where there's only one step missing, the easier it's going to be for the model. And at some point it probably should be.
I suspect that is true, but that seems like it would be a test that's quite.
It's going to be for the model, and at some point it probably should be.
I suspect that is true, but that seems like it would be a test that's quite difficult to scale or to get like very many data points from. It would be an interesting test, but I'm not sure. Like, I guess I was kind of biased towards tests which would be easier to do or easier to run when I was writing this essay. In part because I was thinking of running some of these tests myself. And that one seems quite hard for any task which is kind of involved.
Okay, I had another funny idea, if you don't mind. And that is like the internal emails of Enrun are publicly available. And I imagine what in you look at some random email thread and then you ask like, what is that person trying to do and what is that person trying to do, and try to see if you can then possibly it will be able to like get enough theory of mind to say, okay, that person is actually trying to hide the truth about the state of the electrical grid in California, and then if you do that with a number of email threads, then maybe you can figure out, okay, it looks like that this person called Bob, he tried to hide this specific kind of information through all his emails. Do you think something like that would be, I think, like since the information is actually there, like the email correspondence is there, it would be interesting to see if there's something we can do with that. What do you feel about this kind of experiment?
Kind of suspicious that people before would be able to keep track of these things, but then again, like it was able to do some pretty impressive stuff in Minecraft with just a simple vector database and access to a admittedly very powerful API. But yeah, this seems like it would be a relatively easy test to run. I don't think you'd get very far with it. I think this is like more the kind of test which I expect GPT-5 would make progress on. But yeah.
I will comment on this topic as well. I did some experiments on GPT-4 about whether it's able to detect manipulation. There are many kinds of manipulation. And in particular, I was not focused on any fake news or wrong information, which is you can verify from database, but just manipulation as psychological, on any fake news or wrong information, which is you can verify from database, but just manipulation as psychological approach to communication. And I searched, there are various sort of dialogues in Quora and Reddit, and I just copied them to the ChatGPT and asked it to describe the communication style of each party, and then also explain why it thinks this party has this and this communication style. And to make this question more clear, I also then gave it some list of manipulation tactic names of manipulation tactics. And it was very well able to point out where particular type of manipulation tactic was present in the words, whether some of manipulation tactic names of manipulation tactics. And it was very well able to point out where particular type of manipulation tactic was present in the words, whether somebody was sort of dismissing or diminishing or aggressive or any kind of influence which is not exactly lie, but it tries to change how you think. I think that's very interesting, and I will continue this sort of experiments myself, at least.
How much detail did you get it to be able to detect? Like, was it only able to tell whether someone was being aggressive, or were they able to tell what they were being aggressive about, or like what their goal was in the conversation? Because I feel like sentiment analysis is fairly simple and something you wouldn't need a large language model for. But if it could detect that, oh yes, this person is trying to manipulate an explanation of why this person is being manipulative, why this manipulative person said this particular line, that would be very impressive.
Okay, so I did not try it in the sense that what GPT-2 gave me was what I asked about, and I gave it particular labels of manipulation, and over time I extended this list of labels. But anyway, I sort of gave it categorization task. I did not ask about motivation, but even if I gave it categorization task, it still explained its answers. At least in that sense, it was thinking further than I asked. And if I explicitly ask, could you sort of imagine what could be hypothetically the motivation of the participant in this conversation, to explicitly ask, could you sort of imagine what could be hypothetically the motivation of the participant in this conversation to have these manipulative tactics, then yes, I think it maybe could do that. I will try.
That is very cool. If any of you have conducted other tests like this to check for manipulation or deception or strategizing, I would be very grateful if you could message me on Skype what those tests were, because that sounds like useful data. I don't think it's info-hazardous, but I guess use your judgment, right?
Great. Are there any final questions or comments?
Last thing that then presumably when I think Roland was talking about GPT-2, wasn't he? Is that right, Roland? That you did this with?
I did it with GPT-4.
GPT-4. Okay,
Yeah.
well that makes more sense. But anyway, I can say that presumably if it's good at detecting what's going on and the manipulations that are happening in this way, it would also be good at using those manipulations itself if it was asked to. You know, pretend that you're somebody who's upset with the person you're talking to, and how would you reply?
Yeah, definitely. For example, I asked it about not manipulation, but the opposite. Imagine that you are Gandhi or Marshall Rosenberg. Imagine that you are Gandhi or Marshall Rosenberg. He was one of the founders of the nonviolent communication, and as a method. And I asked about various people how particular person would say something or solve particular situation, and it was able to do that. Assuming, of course, that the person is well known.
It's always Gandhi is picked on quite a lot, isn't he? For this purpose.